I'm gonna really try on if you.
Okay,
Yeah, same. So, like,
now I'm ready to solve some problems on worksheet 9-2. First we have a matching, another matching, a fill in the blank kind of thing, then we'll start with problems. So our first four that we're going to work on have as the terms efficiency, law of conservation of energy, percent, and transformation. So let's get started on this. Our units for efficiency are percent, A. Guys, not too loud. I'm doing a, guys, not too loud. I'm doing a, just soft voices. Next, the ratio of work out to work in, how good a machine is. And that is B, efficiency. C, energy can never be lost or gained, just transformed. That, of course, is the law of conservation of energy. And last but not least, changing from one form to another form, and that should specifically be energy, is transformation. B, C, A, B. Let's move over to our next section where we have thermal, nuclear, radiant, mechanical, chemical, and electrical. And all those are forms of energy. I'll switch colors. So energy of the atom being split or fused. That one, and I'm just going to show you something real quick. If you go back to these definitions, you can find all of your answers. So our first one will be nuclear energy. B, the energy of moving electrons. That will, of course, be electrical energy. Heat energy, also caused by friction, and feel free to go look this up, is C, thermal energy. Light energy, which is comprised of the electromagnetic radiation, is radiant energy. Kinetic or potential energy that's stored in an object and can do work is mechanical energy. And last but not least, the energy of molecular bonds gives us chemical energy. So make sure you get those down. As a quick note, these forms of energy are extremely important for you to have on your note cards. Next, we're going to do what kind of energy, and we can put thermal, I'll put a T, nuclear an N, radiant R, mechanical M, chemical C, and electrical, I'll use an E. A ball on top of a hill would give us mechanical energy or potential energy, and potential energy falls under the umbrella of mechanical energy. Our first one is mechanical. For our second, the energy in hydrogen. The energy in hydrogen, this one is sort of unusual. A lot of people will come up with chemical energy, but chemical energy is probably not the best answer here. Our best answer will be nuclear. I also get a lot of discussion on how to run a clock, and I'm going to specify that this is a clock that you plug into an electrical socket, so it'll be electrical. People sometimes talk about a wind-up clock, and if it's a clock that you wind up, that would be mechanical energy. Here's another one we have big discussions on, a hot stove. Well, how does the stove get hot? You plug it in, and it uses electrical energy. But the hot part of it gives it thermal energy. So I'm going to say E and T. I'm going to give that a double. Uranium in reactors. Uranium in reactors is generally a radioactive isotope of uranium. So I'm going to give that N for nuclear. Next, on the top of our next column, what is stored in food? And stored in food will be chemical energy. What about given off by the sun? Can I make this bigger? No, I can't. So given off by the sun, that'll be R for radiant energy. A car going 50 miles per hour, that is an example of kinetic energy, which falls under the umbrella of mechanical energy. Our last two are a fire's heat and a fire's light. So we're going to think that the heat is going to be attributed to thermal and the light is going to be attributed to radiant. Both of these are going to come out because of burning, which is chemical. So what energy is used up or given off by a fire? So we have chemical energy that's from our fuel, and we give off light and heat. What energy is transformed from what to what when you turn on a flashlight? So I have a battery that uses chemical energy that is transferred to electrical energy, and that electrical energy is used to power a light, so radiant. I can't write light there, it's going to cross off light. So it'll be battery, electrical, so it'll be chemical, goes to electrical, goes to radiant. And I'll do the rest of this later.